I guess not. Melissa, can you hear me now? Going once? All right, let me continue. Okay, what was I saying? Oh, the tables. Okay, so let me close this. Tables. Okay, so let me download this. Okay, so let me scroll down to where the list of ions. Okay, so this is one chart which contains some common ions and also contains some polyatomic ions, which I'm going to talk about later on. And then there's this other chart. And then there's a third page with this list here. So basically, those are the charts you'll be using to answer questions like these. So I was trying to confirm manganese. Now, according to this, manganese has two types of ions, the +2 and the +4, right? Manganese 2 and manganese 4. So going back to PowerPoint, right? I'm going to write down here that Mn2 plus and Mn4 plus are the two ions. The oxide contains the negative charge. So the question now becomes, what would be the formula for the compound formed between each of these and the O2 minus, right? So between these two, the charges are equal in magnitude. So therefore, the formula for that would be MnO, right? However, if the Mn4 plus combines with this, you're going to need two of these, right? Because you have a +4 charge here, you have a -2, so you have to multiply this by 2 to get a total of -4 here. So when you put these together, the answer becomes MnO2. All right? And that's how you get the name, and well, get the formula for these two compounds. All right? Let me draw a line here so as to avoid confusing that with the next one. Now, in the case of the next one, it's a combination of aluminum and chlorine. So if you consult the tables, you see that aluminum has a +3 charge and the chlorine has a -1 charge. So that's a chloride ion. So you'll see that you have +3 here, you have -1 here. So you need to multiply that by 3. When they combine, you're going to end up with AlCl3 as your final answer. And then for the last one, you have cobalt and bromine. Now I know that cobalt can exist as CO2 plus and CO3 plus. The bromide will have a -1 charge. So what do you think is the answer when you combine the cobalt 2 plus with the bromide?
COBr2.
COBr2, correct, because you're going to need two of these. And what about this one?
COBr3.
COBr3, exactly. All right, because you're going to need 3 of these in that case. Okay, so what I've done so far is to determine the formulas. Now we have to write down the names, right? That's what the question is asking for. So the name of this one would be calcium sulfide. The name of this one will be potassium fluoride. All right? Okay, so what do you think the name of that compound is? MnO. Anybody?
Manganese oxide.
Not quite. Manganese is a good start, but you have to indicate which one. The one with the +2 charge or the one with the +4 charge. So that means you have to include what?
+2.
You have to include a number representing the charge in Roman numerals.
Oh,
So it's manganese 2 oxide. All right? So based on that, what would be the name of the other one?
Manganese.
Manganese
Or oxide.
or oxide. All right? Okay, what about this one? What's the name of that compound?
Aluminum.
Aluminum.
Roman numeral 3.
Nope. And I'll tell you why you don't include the Roman
Oh,
numeral.
because there's not two different.
Exactly.
Okay.
Aluminum can only exist as aluminum 3+ ions. So therefore, according to the rules, it would be redundant for you to include the Roman numerals in that case. So that leads us now to COBr2. What say you is the name of that compound?
Cobalt.
Cobalt,
Roman numeral 2.
cobalt 2. What?
Bromide.
Bromide, exactly. Yes, ma'am.
So on the aluminum and chloride, how come it's not aluminum tetrachloride?
Okay, because we don't use prefixes for ionic compounds. Remember the difference? Well, one difference between naming ionic compounds and naming molecular compounds is that in the case of molecular compounds, prefixes are used. But in the case of ionic compounds, compounds formed from ions, we do not use any prefixes. All right? And the last one. What is the name of the last one?
Cobalt 3.
Cobalt 3 bromide. Okay, very good. So, based on what we have just covered, you should now be able to do these questions I'm about to give you. At least the first part. Ouch. So I want you to focus on parts A and B. Take one and pass.
Let's see. Give her another one.
Okay, so focus on parts A and B. In fact, let me help you out with a couple of A questions. So let me discard, no, let me keep this. And let me go here. And what am I gonna do? Let me go here. We go here. Let me go here. And let me go, where am I going? Here. Oh, by the way, I don't know if, let me see here. Miss Narayan, can you hear me? Okay, I was about to tell her that I'm going to publish. Oh, it's published already. She can go there and download it. Oh, she did answer. Yes, okay. So you can download the assignment for chapter 4. It's published in Canvas, all right? We're focusing on parts A and B for now. So let me bring up this here. Part A is what we're going to look at. Okay. So in part A, what they have done is that they gave you in the extreme left column, in each case, a metal and a non-metal, right? And what they're asking for you to do is to write down firstly the formula and then the name, all right? So you're going to need that chart I mentioned before, right? Because that gives you the list of ions, right? It gives you the charges of the ions. That's what you're going to need to solve this problem, all right? So for the first one, if you go to the charts, what do you see for the formula of Be? The formula for the ion charged, the ion formed by beryllium.
2.
Okay, so the symbol for the ion would be Be2+, right? What about the fluoride? What's the charge, or what's the formula for the fluoride ion? Okay, so minus one, right? So basically, we need to get the charges equal. So how do we achieve that in this case? We have a +2 here. We have a -1 here. So how do we achieve the charges being canceling out?
Times fluoride by 2.
We multiply the fluoride by 2. So therefore, when you put this together, the final answer becomes BeF2. All right? So now we have to name it. So how would you name this compound?
Beryllium
Beryllium
fluoride.
fluoride. All right, very good. Okay, what about the next one? What's the formula for the potassium ion?
Potassium is K.
Okay, what? What's the charge for the ion?
Just guessed that last one.
Yeah, you need to bring up that table.
That's what I'm doing now.
Yeah.
I'm surprised I got it right though. My guess would be the 1.
It would be what?
+1.
+1, yeah. So that's +1. And for the sulfur, or the sulfide, that would be the ion.
-2.
-2,
It'd be S
or
minus
2 minus, same thing. Okay, so in this case here, how would you achieve the cancellation of the charges? You have +1 for the potassium, -2 for the sulfide, so what?
times potassium by 2.
Exactly. So what's the final answer for the formula?
Potassium, Roman numeral 2,
No,
sulfide.
no, not Roman numerals, formula.
Oh, formula K,
K,
Roman numeral 2.
not Roman numeral,
No, K2.
yeah, and then.
Oh, okay, so for the name, for the formula, you don't have to.
Exactly, you don't use Roman numerals in the formula, just in the name, and only for those ions that can display more than one charge. Okay, so what's the name?
The name is potassium,
Potassium,
Roman numeral 2.
no,
No,
potassium what? Sulfide, exactly.
when it,
You wouldn't use Roman numerals here because potassium only displays one charge, and that's +1. You only use Roman
Oh,
numerals
yeah,
when
if
you
there's
have the
2 different-
possibility of 2 or more charges, like copper, cobalt, and those, right? But not in these cases. All right. So let me hear what you have to say for lithium and oxygen. What's the charge carried by the lithium ion?
um,
+1. And what's the charge carried by the oxide ion?
-2.
-2 or 2 minus, same thing. Okay, so what do we do next?
U times lithium by 2, so it'd be Li2.
Exactly, Li2.
Oh,
And what's the name?
lithium oxide.
Lithium oxide, very good. All right, so I think you should be able to do the others. So I'm going to leave you to try those. If you have any questions, feel free to ask. I'm here for that reason.
Which table's PDF? Is it
Um,
one?
If you go to files,
Yeah,
hold on, let me get over this here. Um,
okay, I see.
if you go to files and then go to files and go to tables. And then you're going to see tables chemistry. And that will bring up the packet,
Yeah,
right? And then scroll down, you're going to see 3 pages of ions.
on page 4.
Yeah. It is, yeah.
So Mister, if there is a possible for two charges, we do put both though.
For which one?
For like part B for number two, it's iron 3, nitrogen 2.
Which one?
Part B.
Oh, okay, now you have to, no, in this case, you have to determine which of the charges that the iron would carry. No, the key thing for this one is, let me, get my pen thing working. Okay, so in this case here, there are, I'm gonna write it over here. You have 3 iron ions and you have 2 nitride ions. Now, as far as the nitride is concerned, that carries a -3 charge, right? So the question is, what's a charge? I'm gonna call it X. What's the charge on the iron ion, right? Now, remember, the total charge carried by all of this
That's equal that.
has to be equal to the negative value of this, right? So I'm gonna put 3x minus or plus 2 times -3, and that sum would be equal to 0. Right? So all we have to do is solve for x, and if you solve for x, you're gonna see that that is equal to +3. So that tells you that the charge carried by the iron would be +3, and therefore, the name of this compound, I'm sorry, what am I saying?
No, it would be
+2. Not 3, my bad. Ah, so the name of this compound is iron
iron 2.
2 nitride.
Okay.
So you have to figure out which one it is. Because iron can exist as +2 or +3. So you have to figure out. I have to do something similar for this one, this one, this one, this one. Let me scroll down here. And for number 9, and that's it.
Okay.
So you have to figure out, just like how I figured it out here for the iron in that question, you have to figure it out for the others.
Thank you.
Uh-huh.
Selenium at?
Selenium, so you're talking about the chart?
Well, it's SE, like
Uh,
where in the.
34.
page?
Selenite ion?
Oh. I think.
Yes, sir.
Can you open number 11 on page 2?
Number 11. Oh, okay, so in this case here, let me turn this on.
Use why it has.
Okay, so chromium, now here, this 6 here indicate that the charge on the chromium is +6, right? And the phosphide has a -3 charge, right?
Yes.
So to get the charges canceling out, we're gonna need two of that.
Yeah.
So the final answer is gonna be CrP2.
Alright, so it's. The thing that confused me is chromium has a positive charge of either 3 or 2.
Oh, yeah, it can also be +6 as well. They don't have that on that list. So in this case, I would just go by what is in the question.
Okay,
Yeah.
that's what was confusing. Well,
Hmm?
number 12.
Number 12,
You have to cross multiply for that one.
number 12, okay, so in that case, it's gonna be vanadium, this is 4, so that'll be a +4. And then the nitride would be -3. So yes, you're right. So basically you have to multiply this by 3, multiply this by 4.
B3 and 4.
B, 3, and 4, exactly.
Okay, so it is okay to put a 4 point.
So the Roman numeral in the middle, is that for the charge or is that for like the subscript?
It's for the charge,
The charge.
exactly.
Like, on number 3, on part B,
Number what?
number 3,
Hold on 1 minute. Number 3 on part B.
yeah, TI is 1,
Okay, so let me look at the tables here. Oh, to write down the name, okay. Let me clear this. Okay, so in the case of titanium, we don't know what the charge is because titanium can display more than one charge, right? I'm gonna call it X. And the bromide, each bromide ion carries a -1 charge, I'm sorry. And there are 3 of them, right? So what does that mean in terms of the charge for the titanium? If these 3 carries a total of -3, oops. If these 3 carries a total charge of -3, then what would be the charge carried by the titanium?
be like, you'd have to divide both sides by 3, right?
No, remember the total number of negative charges must be equal to the total number of plus charges. So what would be the total charge for the X, for the titanium? +3, exactly. So therefore, the name of this compound will be titanium 3 bromide. And that's how you name it.
So on number 8, the BE is positive and the hydrogen is positive.
To the right of helium on that chart, there's a negative hydride as well.
Oh, there it is.
Oh,
That's
okay.
confusing.
It spooked me up a little.
Thank you. On 14 with cobalt being the +3 and oxide being -2.
14. Okay, what about it?
So if it's the cobalt is +3 and oxide is -2.
Right.
The 3 in the Roman numerals, is that like the final thing or so like?
Yeah, that's a charge. So in that case,
It'd be C +3 and then O
Right.
-2, and then you have to make them
it's
equal.
gonna be C O +3 and O -2. So what do you think you need to do in that case?
Like
Multiply what?
the 3 and the 2.
Multiply 2 here, 3 here. And therefore the formula becomes CO2O3. Ouch. Okay, it's now 3:15, so we're gonna stop here for today. Let me just check something out here. Okay, so if you're not finished with let me see here. Okay, in part B, you do up to question number 20. That's the best you can do as far as what we covered so far. So next class, we're going to learn how to name the other compounds, all right? So we're going to stop here for today. Let me remind you that your first test is next week, and unfortunately, I was not able to complete grading assignment number 3. I'm going to work on that tonight, and I'm going to post the answer keys for all the assignments so that you can have that to review in preparation for your upcoming test, all right? So something for you to look forward to. All right, so that's it for today, folks. I'll see you guys next